everyone, today we are going to be talking about dividing polynomials, but we are just going to do a little warm-up problem where we review how to do long division because it's the same exact process. So today we're going to do 89 divided by 6. So remember, we take the dividend, which is the first number, and put it in the box. And then we take the divisor, which is the second number, and put it on the outside. And then we say, okay, how many times does 6 go into 8? 1 time. And then we go 1 times 6 is 6. And then we subtract 8 minus 6 is 2. All right, and then we bring the 9 down, and then we say, okay, how many times does 6 go into 29? 4 times. 6 times 4 is 24. Subtract, and then we get a 5. So 6 cannot go into 5 anymore, so that means we have a remainder of 5/6. All right, so we're going to apply that same process to dividing polynomials. So this is our first example. I've already set it up with the dividend in the box and the divisor on the outside. So we are wondering how many times does x go into x squared? We're just looking at the first numbers there. Or another way to think about it is x times what is x squared? And x times x is x squared. All right. And now the thing is, we have to multiply that x by x plus 9. All right, so we're going to do x times x is x squared, and then x times 9 is 9x. Okay, and now we subtract. And we're subtracting this whole thing. So the x squareds cancel, and 14 minus 9x is 5x. And now we keep going. How many times does x go into 5x? Goes in 5 times, and now we do 5 times x. Ooh, I almost forgot to bring the 45 down. Let's not forget that. Okay, and now we do 5 times x is 5x, and then 5 times 9 is 45. And we subtract that whole thing, and we have a remainder of 0. Okay, so that means our answer is x plus 5, and the answer to a division problem is called the quotient. Now there's always a couple ways you can think about division and ways to rearrange this problem. One way is to write it as a fraction like that. The other way is to say, okay, whatever I divided out, I can check my work by saying my answer times what I divided out equals the dividend, all right? And so if you were to FOIL x plus 5 and x plus 9 out, you would get our dividend there. Another thing to keep in mind is the degree of our quotient. All right, so this is just using power rules. So if I have x to the 10th power divided by x to the 8th power, the shortcut there is to subtract the powers, and I end up with x squared. The same thing works with dividing polynomials. The degree of your quotient, or your answer, is going to equal the degree of the dividend minus the degree of the divisor, okay? All right, so in this next example, this example will have a remainder, so you can see what that looks like. I've taken the liberty of already writing it out. Just to note that when I wrote the dividend in the box, I rearranged the polynomial in order of descending powers, and that's important to do when we're doing this long division. Okay, so x goes into 2x cubed, 2x squared times. We multiply the 2x squared by both the x and the -3. Subtract. And when we do -3 minus -6, it turns into adding, so we get a positive 3x squared. Bring everything else down. And then we're doing it again. So that would be positive 3x times. And so then we do 3x times x minus 3. And we get that. All right, now we're going to subtract this whole thing. So here's where we just have to be careful with subtracting negatives. The 3x squareds cancel, and then we end up with a -2x. Bring the 7 down. and then x goes into negative 2x, negative 2 times. Subtract that whole thing, and we get a remainder of 1. All right, so we write the remainder the same way we wrote it in our warm-up problem. So we're going to say, okay, the remainder is 1 over the thing we were dividing by. So x minus 3. All right, and that is your answer. Okay, now that's kind of tedious, so we're going to talk about a shortcut we can use, which should be reviewed from Algebra 2, called synthetic division. And it's just an algorithm that kind of takes this process and makes it a little bit faster. All right, so on this next example, we're going to do synthetic division. Something important to keep in mind with synthetic division is it only works if you're dividing a polynomial by something in the form x minus c. So in this first example, if we're trying to do 5x cubed plus 6x plus 8, we can divide it by x plus 2. In this case, our c will just be negative 2. And the process here was we put our c, or our 0, in the box, and then we listed out the coefficients of our polynomial. But we just have to be careful, because if we're missing a power, like in this example, we have an x cubed and an x, but we're missing an x squared, we just have to remember that and kind of add it in as a 0x squared. So when I'm listing out my coefficients, I'm going to list 5x cubed, 0x squared, 6, 8x, and 8. All right, and the process for synthetic division was you brought the first number down, and then we do negative 2 times 5, and put that answer right here, so the negative 10. And then we add those two numbers. And when we add 0 plus negative 10, we get negative 10. All right, and now we do it again. So we're going negative 2 times negative 10. And that's a positive 20. Add, we get 26. Multiply again, we get negative 52. 8 plus negative 52 is negative 44. Okay, so if you get a number here at the very end, that means you have a remainder. So that will be our remainder. So the final step is just to take these numbers and write it as our quotient, or our answer. So we started with an x cubed and we divided by x, so that means the power of our quotient will be x squared, because we subtract the degree of the dividend minus the degree of the divisor. So we're going to get 5x squared minus 10x plus 26, and then the remainder is negative 44 over what we were dividing by, which is x plus 2. Okay, I want you to try this next problem on your own. Pause it and try the next one on your own. Okay, so hopefully you have an answer. Hopefully you recognize that in this case we were dividing by x plus 2 again, so our c was negative 2, and when you do that synthetic division out, there was no remainder, and our answer was x squared minus 2x minus 3. Okay, we have one more example to do, and this is using what's called the factor theorem. So if c is a 0 of f of x, or a polynomial, then x minus c is a factor. That is a fancy way to say if you can factor something out, it'll be a 0. So you'll kind of see what I mean in this next example, but we can simplify f of x by factoring out x minus c using division, and then we keep factoring to find all the zeros. So we're going to solve this equation given that 3 is a 0. So the factor theorem, what that is saying is if you're told a 0, it also means that x minus 3 is a factor. right? Because if I plugged a 3 into this, we would get 0. So another way to think about that is that c equals 3. So c equals here 0, and then x minus c is a factor. That's all the factor theorem is saying. All right, so I've already set this problem up using long division, and we're going to factor out x minus c, and just kind of pay attention that we put our 0 here in the box. All right, so we bring the first number down. Add. Oh, whoops, we'd get a positive 6, and hold on, I have the wrong sign there. Positive 6, then we get a 3. 3 times 3 is 9. Add those up, we get a negative 2. 3 times negative 2 is negative 6. And we get a 0 here, which means we don't have a remainder, and you can give yourself a little smiley face for no remainder. Okay, so now we've taken this polynomial right here, and we've divided out, we've factored out x minus 3. So if we factor something out, we can put it in front, and then what we have left over is right here. So we have 2x squared plus 3x minus 2 left over. So we've partially factored this polynomial. All right, and now we're just going to continue factoring it, and we need to continue factoring this part right here. So we can factor that by rewriting the middle term and factor it by grouping. So let's see here. We're looking for factors that add to negative 4 and, multiply to negative 4 and add to 3. So that would be 4x and minus 1x. So we rewrote the middle term. Now we factor by grouping. Factor out a negative 1. And so we get 2x minus 1 and x plus 2. And then we can bring down this other factor in front. So now we've fully factored this polynomial. And now we can just solve it by finding our zeros. So zeros occur where x is 3. We can set this equal to 0 and solve, and we'll get x equals 1/2 as a 0 and negative 2. So we have just solved this equation. That's our final answer. Thank you guys so much for watching.